One of the key elements that make great games unforgettable is the enemy AI, whether it's a gang surrounding you or experts taking tactical positions. In this devlog, I'll explain how we built the AI system for our enemies and the logic behind controlling huge group of enemies. To start, we implemented a line of sight system so the enemy can actually see us, figure out where we are, and start chasing. Aside from the attacking enemy, we also coded a system for passive enemies to circle around us at a certain distance, allowing them to maintain their spacing. As the number of enemies increases, the system dynamically makes room for new additions, ensuring the spacing between them is always maintained. Nice. Next, we used a motion matching system to make the enemy run towards us. Sometimes the enemy even acts cute to try and trick us. After that, we set up an aim offset so the enemy track us with their gaze, and we completed the preparations for the enemy query system. If we continue, when fighting in an area packed with enemies, having them come at you in a single file line is just a bad design. That's exactly where the enemy query system comes into play. Under this system, enemies are divided into 3 groups. The first group is the active enemy, which is the first to strike and attacks as soon as you enter its range. The second group consists of opportunistic enemies, who can take a swing at you anytime they get close enough. The final group is the passive enemies. They navigate based on the query system and won't become active unless you attack them first. After tweaking the settings and taking our first look at the system in action, the enemies initially just pick 2 furthest points and keep pacing back and forth between them. Once we resolved that issue, they began selecting their spots properly and updating their positions according to our location. To get a better look at how the system handles scale, we crank up the enemy count. We noticed that sometimes 2 different enemies would pick the exact same spot, causing them to clip into each other. The fix for this was incredibly simple. We just had to enable the RVO Avoidance setting in the character movement component. That single toggle completely solved the issue, and the system was finally good to go. Finally, we added functions that make enemies run based on their distance from us, so the furthest ones now sprint to catch up. After putting all of this together, here's the final result. Okay guys, that's it for this video. Don't forget to mention your thoughts and suggestions about our game in the comments. Subscribe for the next chapters. Bye! If you'd like to help us out or share your feedback, join our Discord via the link in the description.